Let's now look at Gaussian error linear units, GELU. In this case, we have this input tensor, which has large negative value, large positive value, and then we have the values that are a little closer to zero, both on the negative side and the positive side. So in Gaussian linear units, if we look at this paper that is cited here in this, I'm looking at the Keras documentation. Suppose we would have the same reference here. Uh, if we click on this and see where this goes, yep. So it's the same reference. And in this reference, if we look at this equation, that's what we are using in the GELU case. So if we run this code, where we are using tf.nn.gelu, what we get in the output is this. And in this output, large negative values, they approach zero. Smaller negative values, they are non-zero, but they are closer to zero. And the positive values are as large as they can be. So 1, 2, 3 stays as 1, 2, 3, whereas minus 1, 2, 3 becomes 0. And this is clear from the plot that is here in the paper, where you see that this line, which is the blue line, that is for the Gaussian linear units. You can see that when the values are closer to 0, as opposed to the orange line, which is the ReLU, it doesn't get uh, based on the value. It sort of allows it to stay negative, but then the values are a little smaller and closer to 0. However, if the negative values uh, increase beyond a certain value, let's say in this case, if the negative values go beyond -3, then they start approaching 0 pretty rapidly, and they're almost 0 here by the time it is 4. And so when we look at a value of -1, 123, so let's look here, and as you can see, for -4 we are pretty close to 0, uh, minus 0.0001, and by the time if we try and use another number, let's say 50, the number should, yep. So we are already 0 there out. So if we use a -10, that's where we are. Maybe -6, 0, -5. Yep. So that's where we sort of approach 0 and then and to check, we can manually calculate the values using the same formula that we just saw. And if we plug in the values for x from the tensor we have in the input, let's say if we put value of 2, then we get 1.95, which is the same as 1.95 that we get here. We change this to -4, then we get a value of so we get a value that is pretty small, closer to 0, but for some reason this value is not the same as what we have here, which is minus 0.0001. And I'm wondering why. If we change this to a value of 1, 2, 3, let's say -1, 2, 3, you get the 0. Change it to +1, 2, 3, then we do get the 1, 2, 3 as we did here. So that's how we can use the Gaussian error linear unit. If you have any questions, comments, or suggestions, please do let me know in the comment section below. I hope to see you all in the next video. Thank you.